Okay, today's date is the 18th of March 2020. This lesson is on resistance. I can identify a series and a parallel circuit. I can calculate resistance in series circuits, and I can calculate resistance in parallel circuits. So let's have a look at those. Right, first of all, what are we looking at here? Well, here's a cell. This cell, I'm going to label on the negative, the positive and the negative here. I'm going to draw the current on. We always draw current from positive to negative. For a little note, the electrons actually go round or travelling the other way, but we don't worry about that too much at GCSE. So fundamentally, what are we looking at here? We are looking at a series circuit, and a series circuit is a circuit just with the one pathway. There's only one way for the electrons to travel around here. So one of the important points of this is therefore that the current must be the same here as it is flowing through this ammeter here, because you can't get a different rate of flow if there's only one way to run out, or if there's only one way around a circuit. If the electrons are coming out here, they must be the same amount of electrons flowing per second through here. So I'm going to answer these questions. If you need to take a pause, hit the pause button, and then I will explain the answers. What is the total resistance of the circuit above? Well, what is the resistance of the total circuit? Well, I can see I've got an 18 ohm resistor, 16 ohm resistor, a 6 ohm resistor. This is a series circuit, so all I need to do here is just add all these resistances up. 18 plus 16 plus 6, 8 is 20, 34 plus 6, which equals 40 ohms. What can you say about the current in A1, ammeter 1, and ammeter 2? Well, I think I've already given the answer away. The current is equal. And that's because you can't, in a series circuit, you can't have a different rate of flow in different ammeters. What is the current in A1 and A2? Okay, we're going to use Ohm's law here. We're going to do V equals IR is Ohm's law. So R equals V over I. What's the potential difference? That's the potential difference V. Potential difference. Sometimes we refer to that as voltage, but the actual better word is potential difference. And R equals V over I. So that's 20. Oh, what's the current? Oh, I'm calculating current, aren't I? I equals V over R. The V is 20 and the R is 40, which is 0.5 amps. Good ones among you will remember that 0.5 amps means 0.5 coulombs per second. Calculate the potential difference of each resistor. Well, every single resistor has got a current of 0.5 amps. 0.5 amps. 0.5 amps. So let's do V equals IR for the resistors. Well, for the 18 ohm resistor, it's going to be V equals IR, which is 0.5 times 18, which is 9 volts. For the 16 ohm resistor, it's going to be I times R, which is 0.5 times 16, which is 8 volts. And for the 6 ohm resistor, it's going to be 0.5 times 6, which is 3 volts. And what do we notice? 9 plus 8 is 17, plus 3 makes 20. So actually, what we can see here is that all these voltage in a series circuit add up. 9 plus 8 plus 3 volts all add up to make 20 volts. Let's carry on. Okay, well, that's where you can do your working. So all that working is nice and clear there. Fine. Part 2, gents. Take a break if you need to and go work through it. This is a parallel circuit. Here's what I mean by a parallel circuit. We've got more than one pathway. So I'm going to label my positive, my negative again. I can see now some of the electrons are going to go around this way to the 6 ohm resistor. Some of them will go through 16. Some of them will go through, because here we've got the same resistances, but they're connected in a parallel configuration. So I've got current here, and comes all the way round and comes back into here. Now, at these points here in the circuit, we get a break. Some electrons will flow down there, and some will flow down. So the current here is not, I'm going to call these currents, I'm going to call this I1, I2, and I3. Okay, let's try and answer these questions then. Is it easier or more difficult for electrons to flow with the same resistance in parallel than in series? Have a think about that. Well, in the previous question, we looked at the 18, and if you think each electron had to push through each resistor. Once it pushed through that one, then push through that one, and then push. And that's going to be pretty difficult for each electron because they've only got so much energy from the cell. The electron's only got 20 joules per coulomb, 20 volts. This is going to be a bit easier because each electron only has to push through only one of the resistors. So I would say it's easier because they're only pushing through one resistor as opposed to all of them before. Is the current the same everywhere? Well, no, it's clearly not because it splits at junctions. Remember I said here? So if the current comes down here and some of the current goes down here, and that's flow of electrons, then not all of it's going to go down here. So we've got different currents in a circuit. Which resistor gets the most? Take a pause here if you want to have a think about that. Well, if you look at all of these circuits here, they all get 20 volts. Every single one here is getting 20 volts. 20 volts and 20 volts. But not all of them have the same. Which one of these resistors is easier to get through? It's actually this one. This has only got 6 ohms. We can actually calculate what the current is in there. Let's do the so V equals IR. I equals V over R. Let's do that for the 6 ohm resistor. I equals 20 over 6. 20 divided by 6 on my calculator is going to be 20 divided by 6. 10.33 recurring. I'm going to write 10.3 amps. I'll do it for the other one, the high ohm resistor. I'm going to do I equals V over R, which is 20 volts again, but divided by 18. This is probably going to come out less. It's going to be 20 divided by 18. 1.1 amps. If you want to, go ahead and calculate the current in the 16 ohm resistor. Okay. Let's moving on. Take a break if you need. Okay, we've done that. Okay. Final point of the main lesson here. I've got 2 circuits. I've got a circuit with just one resistor of 100 ohms. And I've got another resistor here. I've got another circuit and it's got a 100 ohm resistor with a 200 ohm in parallel. This is series. Just a simple circuit, this one. This is a parallel. Which is the bigger resistance? Well, take a pause here if you need to. Well, it might seem on first glance that this has got a bigger resistance because, look, this has got a 200 ohm resistor and a 100 ohm. But if you think about it, this has got one pathway. On top of that pathway, it's got another pathway. This has got the same pathway as circuit 2, but it doesn't have any other pathways to help it. So any electrons have to push through this one. In circuit 2, we have one pathway of 100 ohms, which makes it just as easy as circuit 1, but we've also got an additional pathway. It's not as good as the 100 ohm pathway, but it does allow some current through it. So the actual bigger resistance is circuit 1. Why? It's only got a single pathway of 100 ohms. Okay, this is proper extension work here for calculate the resistance of circuit 2. So this is not on your GCSE syllabus, but for some of you who are interested in doing this. The actual resistance of this is less than 100 ohms. I'm going to show you how to do it. 1 over R total, that's short for total, equals 1 over R1 plus 1 over R2. So where R1 is going to be that one and that one. So let's put those numbers in. 1 over 100 plus 1 over 200. I can change that 1 over 100 is actually equal to 2 over 200, isn't it? So that's actually equal to 3 200ths. And that's what 1 over R total is. Then R total must equal to 200 over 3, which is, well, my calculator, 200 divided by 3, 66.7. Not required for the GCSE, but if you want to include that work, that is always good. Okay, a little bit of extension for you. So if you're doing well, you want to try yourself out, try answering these questions, and I'm going to show you the answer now. Show the total resistance of this circuit is 12 ohms. Okay. 1 over R total equals 1 over 36 plus 1 over 36 plus 1 over 18. Simple way to realize that is that 1 over 18 is equal to 2 over 36. So we got 4 36ths here, which is 4 36. So 36 divided by 4 equals 9. 1 over 9, which means my initial, so that's that one. So that means R total equals 9. But my R total here was just for that section there. That was those 3 resistances, 9 ohms. Now I've got to add on to this for the full circuit. For the circuit, we've got to add on R equals 9 ohms from that parallel section plus the 3 ohms from the series section, which is 12 ohms. So I had a mistake there. So the current in the ammeter is 1.5 amps. Oh, that's quite a tricky one here, actually. So we're looking for the current that's feeding these two. So I'm going to do this. So the current in the circuit, V equals I R. That tells me I equals V over R, which is 24 divided by 12, which is 2 amps. So that's 2 amps. Here though, that's 2 amps in the whole of the circuit. It's not telling me the circuit, because this is actually going to be, this is going to have the current these two before this one. So if I've got 2 amps here, the easiest way to do this is to actually work out what the voltage is across here, because there's going to be a voltage across. So I'm going to do that now. What's the voltage? V equals IR, which is 2 times 3, which is 6 volts. This is going to be 6 volts, which means this is now 18 volts. I equals V over R for this section down here is going to be 18 over 18, which is 1 amp. That's that bit here. And what's this one going to get? This is going to get I equals V over R, which is, again, it's going to be my 18 volts divided by 36, which is 0.5 amps. Now that does actually make sense, because if that's 36, that's going to be 0.5 amps. And this one is also 0.5 amps. And this is 1 amp. So what do we see? 1 amp plus a half gives us our 2 amps. Therefore, current in ammeter equals these two, because these are the two that are going to feed into that, which is 1.5 amps. Okay, if you need to go through anything on this lesson, please rewind and go through and take a time. But, thank you. Bye.